Yes. Good evening, dear aspirants. Uh, okay. So in last class we have seen about this introduction to Verilog. So what is the difference between this high-level language and low-level language? Okay, and what are the different types of modelings are there? Like we have discussed about behavior, gate level, data flow, and hybrid modeling. Okay, and we already seen that what is the program, how the program will do. The program will start with the module and it will end with the end module, and how the so this module is nothing but keyword and identifiers, and what are the port list, and how we need to define the identifiers, invalid identifiers and valid identifiers, and style also we have seen how to declare this style. Okay, so we can declare within the port list or we can declare separately, and we already seen that dollar display and some escape identifiers we have seen, like blank space, backspace, tab, new line, comments. Okay, single line comment, multiple line comment we have seen. Okay, so today we'll see about one second, change the color. Today we'll see about the basic constructs in Verilog. Basic constructs in Verilog. So if you see number specification in Verilog, okay. So how we will specify this number, okay, number specification in Verilog, number specification in Verilog, okay. So you already seen in the digital. So how many number systems are there? Mainly we have 4 number systems, no? So that means binary number system. Okay. So if number system have the radix or base, okay. So what is the base or radix for this binary? 2, no? And for the octal you have radix 8, okay. And the range of the number is from 0 to r minus 1. Okay, 0 to r minus 1. So here the range is what, 0 to 0 comma 1, and this range is 0 to 7. And next decimal number system is decimal. We already know, so we can understand this. This is the radix is 10 and the range is 0 to 9. Okay, and next you have hexadecimal number system. Okay, hexadecimal number system, the radix is 16 and the range is what, 0 to f. Okay, so how we will define this number system, the Verilog. Okay, that is our topic. First we'll see the first one, that is binary number system. Binary number system. So if you see the binary number system, the syntax, standard syntax will be like this. You see the syntax: size, and tick. Okay, base value, base and value. Whatever the base is there and the value. Okay, so that means size is nothing but it will says the number of bits, how many number of bits you have. Okay, in the value, how many number of bits you have in the value, and this is nothing but a tick. Okay, need to represent like tick. And next, this one is like a base. Suppose if it is binary, it is represented as B, and if it is octal, it is represented as O, and if it is decimal, it is represented as D, and if it is hexadecimal, it is represented as H. Okay, H. Okay, so this is the syntax you need to remember. Okay, size, tick, base, and value. Okay, size, tick, base, and value. Okay, so suppose I want to represent 0011 is there. Okay, how to represent this one? So this is the 4 tick binary 4 tick. How many bits are there? 4 bits are there. 1, 2, 3, 4. 4 bits are there. So that is the number of bits. Okay, size tick binary. And what is the number? 0 double. Okay. And similarly, you take 8-bit number. Let us take one 8-bit number. Okay, four ones and 4 zeros. Okay, so how you are representing? 8-tick binary. Okay, 4 ones and 4 zeros. Okay, so like this you will represent. Okay, this is binary representation. And second, if you see octal representation, octal number. If you see the octal number, you have the base 8. You have the base 8. Okay, so suppose like the interviewer intentionally he will view this value. Is this the octal number? Is this an octal number? This is not an octal number. No. Why? Because what is the range of octal? 0 to 7 only. Okay. Intentionally he will give like 9, 7, 8 octal like this. Okay. So this is invalid octal. Okay. So by saying this, we are doing means if you are representing this in terms of this number specification in Verilog, so that means that your interviewer will understand that you don't know the octal representation. Okay, that means you need to strong the digital. Okay, then only you can understand the Verilog. Okay, so here the range is what you need to remember from 0 to 7 only. Okay, so what is the size? Let us take my valid octal number. So this is a valid octal number. Okay. So how to represent? So how to represent? You in the number system conversions, you can go through my playlist. I explained this conversion of one number system into another number system. There I said like how to convert octal to binary. Okay, so octal to binary. So that means each and every bit I need to represent with what this is 722. So this is representing as what 111, and this is 010, and this is what this is 010. Okay, now what is the size? Internally it will be converted into binary and it will store in the compiler. Okay, so how many bits are there? You see this one, how many bits are there? 9 bits are there. 9 tick, and this one is the base is octal and it is represented as 722. Okay, so like this you need to represent. Okay, so I think you understood. So that means basically it will be converted octal to binary. Okay, and after that how many number of bits are there, that much size it is represented. Okay, so this is the representation of octal. And next, if you see, let us take this number 55 to the base 18. How to represent? So 55, if you convert into a binary, so this is octal value. So this is 101 and this is 101. So total how many bits are there in the binary? So total 6 bits are there. So this is a 6-tick octal and 55. Okay. So this is the correct answer. Okay. So like this also you can represent. Suppose if you add 2 more zeros in this, you can represent like this. So that is 8-tick, 8-tick octal 55. Okay. So this is also correct. Okay. If you are padding 2 more zeros before this value, the value will not change. Okay, the value will not change. Okay, so this is octal representation. And next, if you represent decimal, okay, third one is decimal, no? Decimal number. So what is the base of decimal? So base is 10. So base is 10. Let us take 53 is there. Okay, 53 to the base 10 is there. So how we are representing? I told you in the digital playlist, we need to convert decimal to any other number system. So if you want to convert decimal to binary, we need to do successive division, no? Integer part and you are getting the reminder. That reminder you need to take from bottom to top. Okay, this is if you are doing successive division. So this is 26, reminder is 1, and next 13, reminder is 0, and 2 with 2, this is 6, reminder is 1, and next with 3, reminder is 0, okay, with 2, so 1, 1, okay, you need to take from bottom to top, okay. How many bits are there? 1, 2, 3, 4, 5, 6, okay, so 6 bits are there. So I can represent this one as size. Size means 6 tick by 6 tick. What is this? This is basis what D. Okay, 6 tick D and the value. Okay, so like this, you need to represent. Okay, you need to represent. Suppose you can practice with like 72 decimal, how it is representing, 124 decimal, how it is representing. I told you the process, no? So you need to convert whatever the decimal value into binary. That much size you need to represent. Okay, you need to represent and you need to write in terms of that size. Okay, and fourth one is hexadecimal representation. Hexadecimal, how we are representing? Let us take some value. FF1 is there. FF1 to the base 16. I want to represent. Okay. So in the playlist, in digital playlist, I told you number conversion, how to convert hexadecimal to binary. Okay. So that means binary octal have the base 16. If you want to represent in 2 power, that is 4. So that means each and every bit you need to represent as 4 bits. So this is what 4 ones. This is 4 ones. And this is 0, 0, 0, 1. Okay. So how many bits are there? So total 12 bits are there, no? So you can represent like 12 tick the radix. What is the base? H, the value, F1. Okay, like this. You can take any example like BABA is there. BABA to the base 16 is there. How we are representing? So BABA, how many bits are required? By seeing this, you can say. So each is 4 bits. So 4, 4, 16, no? So 16 tick hexadecimal and BA. Like this, you need to represent the hexadecimal number. Okay. So suppose like in binary, suppose size is missing. Suppose tick binary 0, 1, 1, 0. Okay. So what is the size? Okay. By default, the compiler will take the size of the compiler is it will take as 32 bits. Okay. It will store like how it will store. So that means 0, 0 up to so on. That is 28 zeros are there. After that, it will store 0, 1, 1, 0. Okay. So in the compiler will store these bits as 32 bits. If you are not defining the okay, we are not defining the size. Similarly, suppose tick O 73 is there. Okay, so tick O 73 means how it will store. So it will store in terms of 32 bits. 32 bits. So how it will store? 0, 0. At last, this is 1, 1, 1, and this is 0, 1, 1. Okay. So you take out 6 bits from this. What you are getting? 6 means this is 26. 26 zeros are there. Okay. 26 in between the 26 zeros are there, and it is represented like this. Okay. Similarly, decimal also. So hexadecimal also. Hexadecimal how we tick 55 is there. So 55 means the size is 32 bit. The size is 32 bit. So the default the compiler will take as 32 bits. Okay. So how it will store 0, 0 up to so on, and 0, 1, 0, 1, and 0, 1, 0. Okay. So remaining bits are zeros. Remaining bits are zeros. Okay? So like this, it will store. Okay. So if base is not defined, default size is what? Default size is 32. That you need to remember. Okay. Interior can ask like tick binary. So what is the size? So that's 32. So like this, you need to do. Next, you have special characters in the Verilog. Special characters in the Verilog. So you have unknown. Okay. So this is nothing but we can call as don't care, or unknown condition, don't care or unknown condition. Okay. So in digital, we always seen what are the values of don't care, either 0 or 1. We already seen in the K maps, no? So depending on the possibility, we can consider that don't care as either 1 or 0. Okay, that we are seeing. And second, you have Z. What is Z? High impedance or impedance. Okay, impedance. Okay, these are the values. Okay, so impedance is nothing but what? Just this is unconnected. Unconnected. Okay, like if you take this one. Okay, so here this is nothing but unconnected or open, we call as high impedance. High impedance. Okay. High impedance. Okay. And next, strings are there. Strings. What are the strings? Strings, if you see, strings are nothing but what are strings? These are nothing but sequence of characters. No? Sequence of characters. Okay. Sequence of characters. Suppose if I consider like VLSI simplified. VLSI simplified. Okay. So each character is of how many bits? Means 8 bits. Each character it will store in terms of 8 bits. So how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 into 8 bits it will store. Okay. 14 into 8 bits it will store. Okay. So these are nothing but strings. Okay. And next is value set. Value set. So what are the value sets we are using in the Verilog? One is 0. So what is the 0? 0 is nothing but logical, low or false condition. Logical low or false condition. And next is 1. 1 is nothing but logical high or true condition. True condition. Okay. And next you have, we already see these special characters, no? X. X is nothing but what? Don't care. X is nothing but don't care. Don't care values is either 0 or 1. Okay. And next is Z. Z is nothing but high impedance. Z is nothing but high impedance. Okay. So these are the value set. Okay. So you need to remember only these 4 values we are going to use in our Verilog. That is 0, 1. Okay. False condition or low, logic 0 or logic low or false condition, logic high or true condition, or don't care or high impedance. Okay. So these are the 4 value sets we are using in the Verilog. Okay. Okay. This is about today's session. So today's session, what we have seen, the basic constructs in the Verilog. So how to define this number system. So binary number system, octal number system, and decimal number system. Okay. So the syntax is size, pick the base value, base and value. So whatever may be the number system you are giving, so internally the compiler will take as in terms of binary. So that size you need to define as in terms of binary. Okay. So if you are not defining the size, so by default the compiler will take as 32-bit. Okay. Whatever may be the number system. Next we have seen the special characters, that is X and Y. Okay. We have seen the special characters X and Z. X is don't care and Z is high impedance. And next string is nothing but if you take any example like A, B, C, D. So space also it will take a string. Okay, 8 bits. Okay, A, B, C, D. So A, B, C, D it will take as 4 bits. 4 8s are around 32 bits each. Okay, so like this, and value set we already see. And this is 0, 1, X, Z. Okay, so this is about today's sessions. I think I hope you understood this session.